In my previous video I've talked about what Huffman coding is and how to create the tree. In this video we're going to look at an actual exam question. From what I've seen so far in the exam, in the specimen and the 2018 exam, students were not actually asked to create the Huffman tree, but they're asked to take an existing Huffman tree and code the different characters. Now this one's worth 3 marks, and the question says a Huffman tree shown in figure 6 was created to encode the string shown in figure 5. That's the string there. The frequency of each character is shown in the brackets. For example, the letter A appears 5 times within the string shown in figure 5. Okay, so in the brackets there, that says that A appears 5 times, G appears 4 times, etc. Complete the code table below. I've placed it up here just to cut it out and put it up here because it's easier for doing this. For characters G, S and H, the Huffman tree shown in figure 6. Code for character A has already been completed. So when I've got here, this is quite helpful to have this because this has been given a binary code. So if I look, A is there. So if I can't remember that zeros go off to the left and ones go to the right, I've been given quite a big clue there. A is 0. A only has 1 digit and it's off to the left hand side, so zeros must go to the left. What you do need to remember is zeros go to the left and ones go to the right. So what I've done is, I recommend you do this when given a question like this, is I've put the numbers on the branches like that, ones and zeros. I've labelled all the branches. So now I can look at G. G is 1 and then 0, so I'll write down 1 0 like that. Okay, because it's 1 there and 0. It's like a pathway to get to it. What I had to go down route 1 and then route 0 to get to G. What about S then? 1 1 0, and H is 1 1 1. So that has given me 3 marks for just labelling my branches there and being able to write down in this table the different Huffman codes, the binary codes for these different characters. Now this is the second part of the question. This gains me another 4 marks to give me 7 marks in total for this question. What I've got here is a question that says the string shown in figure 5 could also be encoded using ASCII. ASCII uses 7 bits to represent each character. How many bits are saved using Huffman rather than ASCII to represent the string? Must show your working. So what I've got to do here is show how I'm going to work this out. So if you look back at this table from before there, if I just place that there, you can see the different characters that I've got there. Okay, so what I need to do is write down the string and then write down the ones and zeros used in that string. So I'm going to start with, I'm just going to write this out. So A is 0, okay, A is 0, G is 1 0. So now you can see I've written out the whole string and then all the ones and zeros that represent that. So I've got H in there, which is 1 1 1 1 1 1, etc. And I've written all my ones and zeros out like that very carefully. What I'd recommend you do it this way, and you leave some spaces between these characters so you can write your ones and zeros. So what I've got there, if I count all those up, it's actually 25 bits. And that gives me a mark according to the mark scheme for doing that. 1 out of 4 marks. Now what I need to do is think about the ASCII. So ASCII, for just normal ASCII, not extended ASCII, normal ASCII uses 7 bits per character. So I've got 13 characters there. Okay, 13 characters multiplied by 7. Okay, so I need to be able to do this without a calculator. So I'm going to do 10 times 7, which is 70, plus what I've got left over, the 3 there, 3 times 7 plus 3 7s are 21, so that is 91 in total. Okay, so that would be 91 bits in total. So now all I need to do is take away the 25 from that to give me 66, and my final answer for 4 marks is 66 bits for that question.